Hi. In my last videos, we discussed about trigonometric ratios as well as trigonometric identities. Today, we are going to discuss some problems which are related on those. ABC is a right-angled triangle having the length of the sides AB is 8 centimeters, BC 15 centimeters, and CA 17 centimeters. They are asking to find out sin A, cos A, and tan A. Now, observe here, if the square of 8 plus the square of 15 equals to 64 plus 225 is nothing but 289 equals to 17 square. That means we can observe very clearly here, sum of the squares of two edges of a triangle is equals to square of another side of that respective triangle. That means this triangle is nothing but a right angle triangle. The reason because it holds Pythagorean theorem. By using that, I can able to take it is right angled at B because the side length CA is given 17. So the side CA is quite opposite to vertex B. So it is 17 centimeters. Now, if I consider it as vertex A and it has vertex C, AB length given 8 centimeters and BC length given 15 centimeters. Now, they are asking to find sin A. That means the angle of sine with respect to vertex A. That means observe from triangle ABC, we know that sin A means the sine ratio value is nothing but opposite to the respective angle to the hypotenuse. So with respect to A, the opposite side is BC upon hypotenuse is AC. So the value of BC is 15, the value of AC is 17. So the required value of sin A is 15 upon 17. Similarly, cos A. Cos A is nothing but adjacent to the given angle upon hypotenuse. With respect to A, the adjacent side is AB and the hypotenuse will be AC. Now, AB value will be 8 and AC value will be 17. And we want to find tan A also. Tan A equals to, here observe, opposite side with respect to A is BC upon hypotenuse will be 17. But tan formula is what? Opposite upon adjacent. So that is nothing but AB equals to BC value is what? 15 here. AB value will be 8. Or else we can able to write the same one. We know that tan A equals to, we can able to write sin A upon cos A. Sin A value is what here? 15 upon 17 whole by cos A value what we got? 8 upon 17. So 17 get cancelled. Again we got here 15 upon 8. I hope it's clear. Let's see. If 3 tan A equals to 4, then find sin A and cos A. Now, given 3 tan A equals to 4. So, we can write it as tan A equals to 4 upon 3. Why? 3 is in multiplication. When we are bring it to the right side of the equal, it becomes division. Tan is nothing but what? Opposite upon adjacent. So if we are taking a right angle triangle, suppose I am taking it as vertex A, it is right angle at B and C. Opposite to A, that means the length of BC is 4 and adjacent to A is 3. Now I wish to find AC. So AC equals to square root of AB square, that means 3 square, plus BC square equal nothing but 4 square. Square of 3 is 9. Square of 4 is 16. That equals to root 25. We have to take plus or minus 5, but we have to take only plus 5 because the length never be negative. So here the hypotenuse value will be 5. So here I want to find sine A. To find sine A, we already discussed in the previous problem opposite to angle A upon hypotenuse. That is nothing but 4 upon 5. And cos A is nothing but opposite, that means adjacent to angle A upon hypotenuse. So adjacent side to the angle A is 3, hypotenuse will be 5. This is the one method we are finding the values of sine A, cos A by using right angle triangle. Without using right angle triangle, how we can find out by using trigonometric identities? Let's see. The same question we are discussing in another method. We got here tan A equals to 4 upon 3. But we know that secant square A is nothing but 1 plus tan square A. So I can write it as 1 plus tan A is 4 by 3. Tan square is nothing but 16 upon 9. So 1 plus 16 upon 9 is nothing but 9 plus 16 upon 9. It is equals to 25 upon 9. Now secant A equals to square root of 25 upon 9. 25 square root will be 5. The square root of 9 will be 3. So secant A equals to 5 upon 3. But secant is the reciprocal of cos. So cos A is nothing but 3 by 5. I hope you observed before we got the same value. So this is cos A. But I want to find sin A. We know that sin A is nothing but square root of 1 minus cos square A. Why? The reason is we know that sin square A plus cos square A value equals to what? 1. So by applying that identity, we got sin A equals to square root of 1 minus cos square A. That is equals to square root of 1 minus cos A will be 3 upon 5. The square of 3 is 9 upon square of 5 will be 25. That is nothing but square root of 25 minus 9, 16 upon 25 equals to 4 upon 5. This is the value of sin A. I hope it's clear. So here, cot theta given as 7 upon 8. They are asking to find the value of 1 plus sin theta times 1 minus sin theta upon 1 plus cos theta times 1 minus cos theta. We can do this problem by using the previous concept, by using the right angle triangle. Cot is nothing but adjacent upon opposite. So 7 is the opposite side, adjacent side, then 8 is the opposite side. So we can find the hypotenuse, then we can find separately sin theta as well as cos theta, then you can replace the value, you will get the answer. That is the one method. Better than that, if you are know about idea of trigonometric ratios as well as an algebraical identity, that is, we know that a plus b times a minus b is nothing but a square minus b square. By applying that, 1 plus sin theta times 1 minus sin theta upon 1 plus cos theta times 1 minus cos theta equals to a plus b into a minus b. Here a is nothing but 1, b is nothing but sin theta. So we got 1 square minus sin square theta upon 1 square minus cos square theta. But we know that 1 minus sin square theta equals to cos square theta, as well as 1 minus cos square theta equals to sin square theta. That means we can use this trigonometric identity. We can write 1 minus sin square theta is nothing but cos square theta upon 1 minus cos square theta is nothing but sin square theta. But we know that cos theta upon sin theta is nothing but cot theta. But here it is cos square upon sin square, so we got cot square theta. But already the given cot theta is what? 7 upon 8. So 7 upon 8 whole square. That means 7 square is 49 upon 8 square will be 64 is our required solution for the problem number 1. I hope it's clear. Then what about the problem number 2? Let's see the second problem. They given 1 plus sin theta upon cos theta. Here they given cot theta equals to 7 upon 8. We know that cosec theta equals to square root of 1 plus cot square theta. That equals to square root of 1 plus 49 upon 64. This is nothing but 64 plus 49 upon 64. 64 plus 49. 4 plus 9 will be 13. 1 is carried forward. 6 plus 4, 10. 10 plus 1, 11. 113 upon 64 under square root. Now observe that is cosecant theta value. So cosec theta you got square root of 113 upon square root of 64 will be 8. Cosec is the reciprocal of sine. So sin theta equals to 8 upon square root of 113. While observing cot is nothing but what? Adjacent side upon opposite side. So our adjacent side length will be 7. So we can write directly cos theta is nothing but adjacent side. That means 7 upon hypotenuse. Sine is nothing but what? Opposite by hypotenuse. So our hypotenuse value is square root of 113. Now replace these values here. 1 plus sin theta. Sin theta is 8 upon square root of 113 by cos theta. 1, 7 minus square root of 113. That implies square root of 113 plus 8 upon square root of 113 by this is 7 upon square root of 113. Now square root of 113 and 113 get cancelled. The final answer will be 8 plus square root of 113 upon 7 is the required value of 1 plus sin theta upon cos theta. I hope it's clear to you all. So these are some of the problems which are related on the concepts of trigonometric ratios and identities, and some more problems we will discuss in my next video. Thank you. Thank you to all.